Okay, last two problems. This is number 16. In this problem, you're being given the expanded version of the double angle formula for cosine. If you recall this formula or look on your formula sheet, it goes like this. Cosine of double any angle in its expanded form would be equivalent to this. 2 cosine squared theta minus 1. So what you're seeing is this, and you're going to bring it back to the condensed form. But notice that there's a theta here and a theta here. So when you bring it back to this form, whatever angle you've been given, you will also write here. So it's cosine of a double angle, bringing you to cosine of 210. So you'll finish the problem by rotating to 210, go to 180, then go an extra 30. So that this arm right here is at 210. That makes this the short leg, and it is negative because of the quadrant it's in. This would be the long leg because the 60 would be here. And across from the 60 is always the long leg. It is also negative. X's and Y's are negative in this quadrant. And then this will be 2. Finish the problem using the picture and the definition of cosine, which is x over r. So in this case, the x is negative square root of 3, and the r is 2. Okay, last problem. You're being given cosine of 75, which is not something that you can calculate an exact value. So you're going to rewrite it using values that you can calculate exact values for. So that would be 30 added to 45 would give you the 75 that you're seeing there. And then to go from this condensed form into a form where you can draw triangles for each separate angle, you're going to use the formula for the sum of cosine. So that's cosine, cosine. Switch the sign, and then it's sine, sine. You're going to need to know the numbers for cosine and sine at 30 and also 45. So if you have those memorized, you don't need to draw this. But I would say that it's probably in your best interest for most of you to write it so that you can be looking at it as you plug in, because you're going to create a fraction for each one of these. And those fractions will come right off of the triangle. So for 30 degrees, you would have, and it's really quick to make the triangle anyway, short leg, hypotenuse, long leg. For a 45-degree triangle, it's 1, 1, square root of 2. Come back to the problem and plug in the fractions here. So cosine of 30, remember cosine is defined as x over r, and wherever you see sine, it's defined as y over r. So x over r, using the 30-degree triangle, would be square root of 3 over 2. Cosine at 45 would be x over r, 1 over square root of 2. Then over here in the back product, sine at 30, get back on the 30-degree triangle, and you're using y over r. So 1 over 2. And then last one, sine at 45, you're using y over r again, but in the 45-degree triangle. So 1 over square root of 2. Now I'll do a little bit of arithmetic to pull these two products together into one fraction. This is top times top, square root of 3 over 2 square roots of 2. And since they both have that denominator, I'm going to pull them together into just one fraction, minus, and then here it is 1 times 1 over 2 square roots of 2. Then you're going to rationalize, getting rid of the radical in the bottom by multiplying by square root of 2 on the top as well. You'll be using that square root of 2 and multiplying it by this entire expression. So it's square root of 2 times square root of 3, square root of 6, and then square root of 2 times 1 is square root of 2, and then 2 times 2 again gives you 4. Okay, and that's it for the practice problems.